And then we can start. Okay, let me just move this thing out of the way. Just a second. From the beginning. Okay. So okay, before we start, I would like to welcome you all. This is our t-test workshop. So today we're going to start by describing what kind of test is a t-test. And then we're going to go over the different types of t-tests we have and when we use them. And we're also going to talk about the different kind of specific assumptions related to each different type of t-test. And then we will finish off and we do some practical activities in SPSS using independent and pair sample t-test. So to start with, okay, sorry, we still have some people joining in. To start with, we're going to the first thing we need to focus on is what kind of test is the t-test. So t-test is a type of inferential statistic that we use to assess whether there is a statistically significant difference between two sample means. With inferential statistic, what we do, we make general assumptions of the sample population we collected data from, and we inform the general population. I know this might sound a little bit too complicated, but I'm going to give you two examples, and hopefully it will be very clear what we mean with a t-test. So, excuse me. Imagine we're interested to assess the effectiveness of an antidepressant drug. So we design a study. Let's say we have 20 participants, and we want to see whether there is a statistical significant difference in depression scores before, let's say, our participants receive the antidepressant drug and after. So what we do, we compare the two sample means, which is the depression levels before they took the antidepressant drug and after they took the antidepressant drug. So we run a t-test to assess whether there's a statistically significant difference between these two sample means. So let's say that we do actually find there is a statistically significant difference between the depression scores before and after our participants received the antidepressant drug. And the outcome is that there was an improvement in the depression levels when the participant took the antidepressant drug. So this is the outcome from our research. So we use a sample, 20 participants, and we use our t-test to check whether there is this kind of difference, okay? So because it's a type of inferential statistic, what we can do then, we can make more general assumptions. So we can say that we can make, let's say, generalizations, and we can argue that antidepressant drug is an effective treatment for depression. So we make more general kind of conclusions. So does that make sense, what kind of test and how we use it to do to conduct research? I'm going to give you another example. So similar to the previous one about levels of depression, now in this case, we want to compare two drugs, let's say drug A and drug B, and we want to see which one is the most effective to treat depression. So we take a group of participants and we administer the drug A, and we take another group of participants and we administer drug B. And then we compare the two sample means, and we find there is conducting a t-test, and we do find that there is a statistical significant difference between the two sample means, between the scores in depression in the group that received the drug A compared to the depression scores in the group that they received the drug B. So the outcome of our research is that there is a statistically significant difference between drug A and drug B, And in the case that the drug A is more effective, so participants took drug A, they saw a decrease in the depression levels. And what we can do then, we can go and say, make more general assumptions and say that drug A is an effective drug treatment for depression compared to drug B. So you see, we use our test for our sample to check differences between two means, and then we can make generalization. And why we can do that, because the t-test is a parametric test. So there are several assumptions that must to be fulfilled in order for our inferential statistics to be meaningful. So because we make this kind of generalizations of our research, so we take that sample, but we make more general assumptions, we need to be very strict on these assumptions. When you think about a statistic like a t-test, it's a kind of a module. So as we need to have certain kind of things in place. So when we fulfill these assumptions, then we can be more sure about the general, let's say, conclusions that we make based on our research outcomes. If we violate these assumptions, then our conclusion, we can't be so sure that our conclusions are valid and reliable. So we talk a little bit about what type of test is the t-test. And now we want to go and look at different types of t-tests we have and when we use them. So we have the independent sample t-test, we have the per sample t-test, and the one sample t-test. So the independent sample t-test we use when we want to assess whether there is a significant difference in a variable we measure, which is our dependent variable, between two groups of participants or conditions, which is the independent variable. Going back to our previous example, where we assessed the depression level, so we had two groups of participants. We had participants that received the drug A and participants received drug B. So that's our two groups, okay, the two conditions, which is our independent variable. And we assess their depression level, whether there is significant difference in the depression level, which is our dependent variable. Some of the assumptions like related to the measurements in regards to independent sample t-test is that our dependent variable needs to be interval or ratio. And I refer you back to the first workshop where we talk about the different types of measurements. And our independent variable needs to be categorical with two levels. So in this case, with when we assess depression level, obviously that's within a questionnaire or a measure. So it will be like an either interval or a ratio kind of measurement. So that's our dependent variable. Our independent variable is categorical. So we have two categories. So our participants either part of one category, which is drug A, or drug B. So we have two levels. Any questions so far? Okay. The next type of t-test is the per sample t-test, or as sometimes we call it within subject t-test. So this is a type of t-test. We conduct this type of t-test when we want to compare the scores of the same group of participants on two different occasions or conditions. So again, back to our example, we had 20 participants and we wanted to assess whether the antidepressant drug was effective in treating depression symptoms. So we compare one group, we had one group of participants and we compare them in two occasions, before they received the antidepressant drugs and after. So the same participant basically had two responses, before and after. So again, some of the assumptions of the per sample t-test is that dependent variable needs to be interval or ratio, our depression levels, and the independent variable needs to be categorical with two levels. So we have the pre-drug, let's say, assessment and after drug assessment, antidepressant, okay. And finally, we have the one sample t-test. So we use one sample t-test when we want to compare the mean score of a single group against a known mean. And what we mean with that, so imagine I'm interested to see, I have a group of 5-year-old children, and I want to assess whether they are within the normal physical development, and I want to focus on the height. I know, for example, that the normal height for the age group of 5 is 1 meter, let's say. So what I do, I measure every child in my group. Let's say I have 20 children. And then I compare the outcome that I have from my sample based on the normal height that will be expected for that age group, which is 1 meter. And then I check whether my group is within the normal range. Again, one of the assumptions of this test is that the dependent variable needs to be interval or ratio. This is a type of test we're not commonly used. The two types of tests that we're going to focus and do some more, we're going to look some examples in SPSS is the independent t-test and the repeated measure t-test. So just to recap, we talk a little bit about the type of test that is the t-test. We talk about the different types and when we use them. So we basically talk about research design, some basic assumptions associated with each type of t-test. And now we're going to go and look, as we said, it's a parametric test, t-test. So it has quite strict assumptions that we need to fulfill in order to be sure that when we make conclusions, let's say on our sample data, they're valid and reliable. So we're going to start with the independent t-test. So the first assumption, and some of them we just briefly looked previously, is that our dependent variable, so what we're measuring, okay, needs to be interval or ratio. Our independent variable, so the thing that we manipulate, should be categorical and should be two independent categories. So we have two groups. Then the third assumption, we need to have independence of observations. So it should not be a relationship between our groups. So different participants should be in each group. And this assumption, it relates with a research design. So how we design our experiment. So for example, what we want, if a participant is in one group, so back to our example where we assess depression level when our participants receive, let's say, drug A and drug B, we want the participants that they receive drug A not to be part of in the group of that they receive the drug B. We want each of our participants that they're in each group to be separated, and that's what I'm saying. This assumption has to do with how we design our study. Then we have that our dependent variables should be normally distributed for each group of our independent variable. And what that means, this is something we're going to check using SPSS. And I'm going to demonstrate in a bit how we're going to do that. But what we need to check is not like all the data together. We want our dependent variable for each of our groups. So when it comes, for example, to the depression levels, we want to have a normal distribution for our group that receive the drug A, and then normal distribution for the scores of depression levels for our group that receive the drug B. And finally, the last assumption is there needs to be a homogeneity of variance in our data, which means that the standard deviation of our sample is approximately equal. And again, this is an assumption we're going to check using SPSS. And basically what it assumes is that the variance, like how our data, our raw data are around the mean, vary around the mean, they should have the same variance in each group. So the raw data, let's say, from our group that took the drug A should be the same there should be the same variation as the raw data from our participants from that took the drug B. Okay, and I'm going to demonstrate, and we're going to use a little example, and I think that will start making more sense. So here we have two groups of participants. We have students and we have lawyers. And we calculated the lies that each of these groups are saying per week, like the number of lies they say per week. So what we want to test is whether there is a difference between lying behavior in lawyers and students. So when you think about it, we have our two categorical data. You see, we have our students and the lawyers, and we want to see if there is a difference in the means, in these two means. So we have the mean for the lies that the students say, and we want to compare them with the mean lies that the lawyer is saying. So we need to use independent sample t-tests or between t-tests. Okay, they're like, again, two different ways of saying the same thing, basically. So let's go and open. I think I've shared the files actually with you, the SPSS files. It's in the chat. So if you want, you can open the SPSS files, the SPSS file which says between t-tests, and then we can do these things together. Just going to wait a second to open the file, and then I'm going to start sharing. I think, sorry, let me just share my screen. There we are. Okay. So the first, can you see the spaces?
Yes.
Okay, brilliant. So we go to the variable view. So we see the first assumption, it has to do with our data. Okay, so we have our conditions, which they're the two categories. We have students and lawyers. We define them here. So it's categorical. So our independent variable is categorical. So that ticks the first assumption. The independent variable is the lies that they say per week, which is it's a scale. It's an interval measure. So that's kind of, again, tick the box of one of the assumptions to run the independent t-test. So if we come in the data view, we see our two conditions, our two groups. We have our lawyers and our students, and we have the lies that they say per week. So basically, we want to compare the lies from the lawyers to the lies of the students. So now what we need to do before we run the t-test, the other assumption was related to the standard deviation. So we need to see whether these scores are normally distributed and whether these scores are normally distributed. So how we do that, we go to analyze, we go to our descriptive statistics, and then explore. And we put condition, which is our two basically groups, in the factor list, and number of lies per week in our dependent list. And then we click statistics, and then we click for any outliers. Okay, we want to check whether there is any outliers that they might actually make our data, I don't know, look a bit skewed, or we might have to deal with outliers. That's something we're going to actually cover in another workshop, how we deal with outliers. But we want to check it's like visualizing your data, your raw data. You want to see what your data look like. And then we click plot. So all this kind of, it's tick for us. So we want to see histograms and we want to see the normality plots with tests. This is the important because that will give us again an indication whether our data are normally distributed. And then we press continue. And then we click OK. And I think now I need to share my screen again because that'll be the output. Okay, so what we see here, so you see in the first table, we have some kind of, well, the valid cases. So we see if we have any missing cases. So we have the total number of students, of lawyers. It just gives us again, because now obviously we have only 14 participants, but imagine if we have like 100. So it's a quick way to visualize our data. Do we have, how many do we have in one group? How many participants do we have in the other group? Do we have any missing cases, any missing data, etc. And then we go to our descriptives, which is quite important. So you see here, we have per condition, which is per group, and we have our dependent variable, which is the number of lives per week. So we get a mean value, which is the average, if you remember from our previous workshop. We have our confidence interval, we have median, variance, standard deviation, minimum, maximum, the range. So all these are important values to start making sense of our data. But also the skewness and kurtosis are very important, because what we need these values, and this is something we need to calculate by hand. So we need to take the value of skewness, where it says statistic, and divide it by the standard error, this value. And we need to do the same for kurtosis. And basically what we want the outcome to be for each of the skewness and kurtosis score, we want to be within the range of minus 1.96 plus 1.96. So that's kind of, let's say, the normal range that we want our data to look like. But that's not the only thing that we're taking our data for normality. This is one of the, so this might, let's say, be not within that range. So we're not automatically say, all right, data are not normally distributed. There are other things that we're going to look as well. So they're like, when we decide whether our data are normally distributed, we take like different inputs. Okay, so that's one of them. And as you can see, one of the assumptions for the between subject t-test is to check the normality for each of our group, and that's the output we have. So then it gives us a table with extreme values, and that's important. Give us the highest, the lowest. That's where, for example, if we have an outlier and we see something like, for example, imagine that value was like 80. So that would be an extreme score. So we need to do something with this score, because it's not within the normal range of our normal values for that group. Okay. So again, it gives us a quick understanding and quick indication of what is happening in our raw data. And this is very important, the test of normality. So we have two tests. We have the Kolmogorov-Smirnov test and the Shapiro-Wilk test. So the Shapiro-Wilk test, it works better if we have less than 50 cases, 50 participants in our sample, which is the case here, and that's the one that we're gonna focus on. So it's a bit tricky, this one, because normally we want our p-value. You see where it says significant, that gives us our p-value. So when we do statistics in general, what we want, I mean, what we're looking, if there is, let's say, it's a statistical significant difference, we want our p-value to be less than 0.05. And that's when we say there was a statistically significant difference. The different kind of, the test of normality works the other way around, because it's based on the null hypothesis. So the null hypothesis suggests that our data are normally distributed. So because it's not significant, okay, our test is not significant, we cannot reject the null hypothesis, which means that our data are actually normal distributed. It's a little bit the other way around. It's sometimes complicated, but what you need to remember, I mean, I explained that, and I'm always getting confused to explain that, because it's the opposite of what we're kind of learning statistics. What you want, if you want your data, let's say, to show they're normally distributed, you want that to be the significant value to be non-significant, really, and then you can argue that your data are normally distributed. Is that all right? Is that clear? So
Yep,
from
so far yes.
okay, so from this we can see that our data seem that they're normally distributed. We haven't seen any odd values and extreme values. So now we go and check our histograms. Here you see like a little gap. Obviously, it's never going to be perfect, okay? But you know, from looking our histograms, it doesn't look that bad. Then we go and check our QQ plots here. So what we want, you want this line, all the scores to be very close to this line. So that looks quite all right to me, actually. And the same for the lawyer. So you see, we look at normal, whether our data are normally distributed for each of our group. So far to me, it seems all right. Then we have our box plots. Here is like, we will identify if there was any outliers as well. So it seemed all fine to me. So we can accept the second kind of assumption and say, yeah, our data are normally distributed. So the last kind of assumption is to do with the homogeneity of variance. And to assess the homogeneity of variance, we need to actually run our t-test, our independent sample t-test. So we go to analyze compare means an independent sample t-test. So where is this condition? We put our grouping variable. So there are two groups, and then we define the groups the way we define them in the variable view. So the way I define lawyers and students is by grouping them 1 and 2. So this needs to be consistent how you defined your categories in your variable view, okay? And then we put the number of lies per week in our test variable. So we click here. I don't think we need to change anything here. And then we click OK. I'm going to go to the output. So what we get here, the first one which says group statistics, we get the number of participants in each of our group. Then we get the mean, the standard deviation, standard error. And then we come to the seg, which they're important because these are values that we need to report when we actually report our output based on APA style. Okay, and I'll show you in a bit what I mean with that. And then we go to our next table. So you see the Levene's test for equality of variance. This is the test that tests whether our our variance in our groups are the same. So you see two rows here. So here the first one says equal variance is assumed. And the second one, it says equal variance not assumed. So this test is basically it's the other way around in the same way as the normality test. So the null hypothesis for the Levene's test suggests that the group we're comparing have equal variance. So because you see the significant level is above 0.05, so it's not significant, we do not reject the null hypothesis. So we conclude that there is an equal variance in a group. So we basically check the first row. This is where we base our outcome. If that was below 0.05, then we will report the second row. Okay. So all the assumptions are meant. So what we need to focus now are t-value. This is what we report, the degrees of freedom, and the significant level. So what we can see, it's our p-value is less than 0.05. So what we can see that there is significant difference between lawyers and students in the lies they say per week. And from the mean values, we can see that lawyers say more lies than the students. If we go back now to our presentation, this is how we would report our data. So what we would say, the difference in lie telling between students, and then we'll put the mean value and the standard deviation. And then end lawyers, again, mean value and standard deviation was significant. Then we put our t, degrees of freedom, then our t value, and then we report p is less than 0.5. And then we make, obviously, we can make more general assumptions that we can say that lawyers are telling more lies compared to students in general, not only based on our sample, but in general, okay? So any questions so far?
No, so far
Okay.
good. Thank you.
All right,
Great.
very good. So we're gonna do the same for the related sample t-test. There are less assumptions with a related sample t-test because obviously we don't really have two groups. So all our participants are part of one group. Well, we have the same for our dependent variables. It needs to be interval or ratio. And our data are randomly collected. And again, this has to do with our research design. Dependent variables should be normally distributed, which we will check again in the same way we did for the between subject t-test. And all participants are included in both conditions. So let's go and open our Spss within subject and just check the data. Just a second, let me open the file. I hope it's not going to crash now. Let me just say, I'm just going to wait. It just takes a while to open the Spss. Okay, it doesn't want to open the Spss now. Let me just say. I think it's, is it opening? No. Okay, something happened with my Spss. Okay. Well, just gonna wait a bit and then I'll just try and open it again. Have you managed to open the files that I sent via the chat? Yeah, I think it just crashed. No. Okay, I'm just a second. I need to just, I'm just gonna pause the recording and then come back. Okay, so for the per sample t-test, okay. So as you can see here, we have our dependent variable, which is, we have actually an experiment. Let me explain. So we want to assess the body mass in a group of participants before they went on a diet and after they went on a diet. So you can see pre-diet mass, post-diet mass. So that's our dependent variable, okay? So all our participants basically, as you can see, if you imagine that that's participant 1, 2, 3, they have two scores. So they participate in both conditions of our experiment. So before and after they were on the diet. So the assumptions, let's say, for our data is absolutely fine. So you see the difference with the between subject t-test. So here in theory, we had one kind of output, let's say, and we had two groups, whereas here it's kind of, it's assumed that there are the two conditions, but in essence we have two outcomes, like two scores for each one of our participants. And that's kind of the way you need to, because sometimes even the way you input data, it's a bit different, let's say, from the between subject t-test. So the other thing we need to do now, we need to check whether our data are normally distributed. So the same way, analyze, descriptive, explore, and we put both of our variables independently. So we have the pre-diet mass, post-diet mass. We do the statistics, we click for any outliers, then we do the plots, and we do a histogram and normality plots with tests, and then we press OK. And then we go here. And it's kind of the same output. So the first table, we see the number of cases, okay, any missing cases, if we have any missing cases. So then we go to our descriptive statistics. So we have our mean, our median, our variance, standard deviation. Skewness and kurtosis, we calculate by hand in the same way. I'm not going to do that now, but this is something for you when you run different kind of statistical analysis. That's how you can do it, and that's how you can demonstrate that you check all the assumptions to check whether your data are normal distributed. And extreme values here, again, we assess whether we see something that it's a bit unusual from what we will expect for the highest and the lowest scores. And here we come in our test of normality. So I know it's 78, and I said like the Shapiro-Wilk test, it works better near 50, let's say, when we have a sample of 50, but it's still a small sample. Whereas the Kolmogorov-Smirnov, it works better with larger samples. So do you remember what we want this p-value to be non-significant, which it is, it's higher than 0.05. So what we assume that our data are normally distributed based on the Shapiro-Wilk test. We check also the skewness, kurtosis, and extreme values, and then we go to our histograms. So you can see there's a nice distribution. So what we want our histograms to look like is like this nice bell shape kind of look, and we can actually plot the normal distribution curve. Let me just plot that and bring it up. So if we go to the chart there, elements, and then we show normal distribution curve, and then we close it, and there you are. You see, it's a nice, I can see definitely there is a nice distribution of our data. QQ plots, you see, really nice within the line, the data. And our box plot, again, really nice distributed, no outliers. And then we do the same for the post-diet, the body mass after they had the diet. And you see, again, the QQ plots really within the line. So I would definitely say the data look normally distributed to me. So then what we do, we go back and we run our t-test. So we go compare MACE, and this time we'll go per sample t-test. And what we do, where it says per variable, so we compare the two variables for each one of our participants. So we want to compare the pre-diet mass with the post-diet mass. And then we click OK. And again, we have for each one of our condition, pre-diet mass, post-diet mass, we have the mean, the number, standard deviation, standard error, and then we go here, the per sample t-test. So this is the mean difference between the pre and the post, standard deviation, standard error, the confidence interval, and what we want really is the t-value, the degree of freedoms, and the significant level, the p-level, which we can see it's less than 0.05, which we can assume there is a significant difference between pre and post body mass. And if we see from our mean values, we can see, for example, the pre-body mass is higher than the post-body mass. One thing that I haven't mentioned, and I'm gonna it's the same in between subjects t-test. By default version 27, it gives us the effect size, because I haven't covered effect size. I don't want to go and talk about it, but this is something you might look more when you start doing your assignments and your projects, etc. So this is something just keep in mind. Effect size is a common thing now. We report effect size as well. Sorry. So how we report the per sample t-test. So the difference in body mass before, we put the mean value on the standard deviation, and after the diet, mean and standard deviation was significant. T-value, degrees of freedom, then we put our t-value and we put our p-value, which is less than 0.5, which is statistically significant. And that's it for today, really. So do you have any questions?
Not from me. I actually, it was pretty clear, at least from what you have explained. So thank you for that.
Okay, thank you.
Yeah, not from me either, Maria. Thank you very much.
Okay, brilliant. I hope that was helpful.
Thank you. It was very helpful.
Very helpful.
Okay, really, very happy.
Yes, very
Definitely
helpful.
was.
Thank you.